So we're going to start talking about regular polygons again. And we're going to use some of the characteristics of regular polygons to our advantage when we try to think of how to find their areas, right? Specifically, remember that a regular polygon has all sides congruent and all angles congruent, right? So if you want to find the area of a regular polygon, in this case we're going to use a pentagon, what you do is this. You put a dot at the center of the polygon. All right. Now, if you draw a segment from the center to each of the vertices like this, right? How many triangles have we created? 5 of them. That's the number of sides, right? And if you do that, all of the triangles, all 5 of the triangles will be congruent to each other. And because each of the triangles has 2 sides that's coming from the center, right? They're going to be isosceles. All right? Now, let's take a look at the angles in the center, right? This whole thing like this is how many degrees? 360. That means the central angle of one of the polygons is going to be 360 divided by 5, which is always 360 divided by the number of sides. Okay? So that central angle is always going to be 360 divided by the number of sides. So in this case, that angle is 360 divided by 5, which is equal to 72 degrees. Okay? Now, the next thing we're going to talk about is this word here. Okay? This is the apothem. Most people mispronounce this and they call it apothem. This is not the apothem, it's the apothem. Okay? And the apothem is the segment drawn from the center of the polygon perpendicular to a side. So for example, if I were to take, here's the center, go down perpendicular to a side, that's A. Right? That's the apothem. And you can go to any of the other sides, right? So take a look here. This one is A, right? It can go to any of the other sides. Like I can draw A to that side and so on. Okay? A, the apothem, divides the central angle into 2 congruent angles. Okay? Now, okay, how do you find area then? Okay, so take a look. This is what shape is this? An octagon, yes? Okay. Each side of an octagon has a length, each side of this octagon has a length of S, yeah? So what's the perimeter of this octagon? 8 times S, 8S, okay? Now, to find the area of a regular polygon, the formula is P times A over 2, or area is half times A times P. That's how I usually write it, okay? Half times A times P. A is the apothem times the perimeter divided by 2, okay? All right, so let's do this. How do you find the area of a regular polygon? Draw one of the triangle, right, from the center it keeps doing that. All right, so draw one triangle from the center to 2 consecutive vertices, just like this. And we usually like to draw that bottom one because it's like, you know, the triangle is right side up. Okay, now, next you want to draw the apothem and bisect the central angle and the base of the triangle. We're going to use SOHCAHTOA, or special right triangles, to find all the measures. And once you've got all the measures, you find the perimeter, you find the area, we're done. So let's do one. Okay. Oh, this is exciting. I love this stuff. Okay. So I need to find the area of this regular pentagon. Okay. The central angle here, so number one, the central angle is 360 divided by the number of sides, 5, which is 72. Okay? Next, we're going to draw the apothem, right? Number 2 says to draw the apothem, which it's done for us here. And we want to find the central angle and the sides. So for example, if the central angle was 72, the apothem bisects the central angle. So this angle here is half of 72, 36. Okay, we can write that down here. All right, let's talk about sides. This pentagon has a perimeter of 40. So how big is each side of the pentagon? 8.
Oh yeah, I did it.
So this whole thing, the side is 8. The apothem bisects the side, so this part is 4. Okay? So that's number 2, right? We drew the apothem, we bisected the angle, we bisected the side. Next, I need to find A. So that's number 3. I need to use SOHCAHTOA to find A. Well, if this is the angle, the opposite over the adjacent is tangent. So I say tangent of 36 is 4 over A. Okay, be careful here, right? Especially on tests when you guys rush, you do the divisions incorrectly. So A is 4 over tangent of 36. And I'll tell you, that will be 5.51. So that's the apothem, 5.51. Yep.
I'm so confused when you got 80.
Oh, because if the perimeter is 40 and it has 5 sides, you divide. So then, next one, find the perimeter if not given. Well, we have the perimeter, right? What's the perimeter? 40. And sometimes it'll be given, sometimes you just have to find it yourself. Last but not least, find the area. Area is equal to the perimeter times the apothem divided by 2. This is 110. Okay, so it's 110.2 centimeters squared. Okay? All right. Okay, so let's see what we're given. Each side length is 10 of this hexagon. Hexagon. So this is 10. All right? Okay, so same thing. From the center, I draw one triangle. Central angle is this, 60 degrees. Okay? Now, bisect, right. So we're going to draw the apothem. The apothem does 2 things. It bisects the side, so this is equal to 5. And it bisects that central angle, so each of these is 30. Oh my God, we've got a 30, 60, 90 triangle over there. Whoa! If the short leg of the 30, 60, 90 is 5, then the long leg is 5 root 3. And I don't need to find that diagonal side. Okay? So, so you can, you don't have to, you can just put it on the diagram. Okay? Okay, so the apothem, okay, so let's see what we've got. The apothem is 5 root 3. Now, what's the perimeter? If each side is 10, what's the perimeter? 60. 6 times 10, which is 60. So the area is the perimeter, it's the apothem times the perimeter divided by 2. Okay, so how much is that? If this cancels to 30, 30 times 5 is 150 root 3 inches squared. Or if you put it in your calculator, it's 259.8 inches squared. All right? How is that looking? Screencast going. It's okay. All right. So let's find the area of each of the shaded regions here. We want to write the exact answer and the approximate answer. All right? So here we go. To find the area of the shaded region, we need to find the area of the circle minus the area of the language. Minus the area of that triangle, right? Okay. So let's do this. Huh? I know, it's okay. All right. So, so from there, right? So that's 4 meters over there. Now that doubles as that side from the center to the vertex of the triangle and also the radius of the circle, right? So let's draw another one. It's a triangle, so it's kind of awkward. We'll draw this, right? So that's the triangle. The central angle is going to be 360 over 3, which is 120. Okay. When I draw the apothem, it's a triangle. I know, a triangle is also a polygon, just like all the other ones.
It says 4, that's what I was thinking.
I know, the triangle, it's like Pluto, right? Am I a planet? Am I not a planet? Right, the triangle too. It's always left out of those like polygons, but it's a polygon. Okay, so when you draw the apothem, 120 divided by 2 is 60. So this is 60. And look, we've got another 30, 60, 90 triangle. Okay. So the 4 meters is the what of that triangle? Long leg, short leg, or hypotenuse? Hypotenuse. If the hypotenuse is 4, how big is the short leg? 2. And the short leg happens to be the apothem. Okay? All right. Now that we have that, we also have to find the side of the triangle. Well, this much here, this is the long leg, so it's 2 root 3, which means this entire thing is 4 root 3. Whew, yeah.
So then would you do the hypotenuse plus the apothem to find the height of the triangle? And then
No. Well, it's half A times P again, right? I know you guys are forgetting. Okay, so the perimeter is 3 times 4 root 3, 12 root 3. So the area of the triangle, okay, is the apothem, which is 2, times the perimeter, divided by 2, 12 root 3. Okay, and I'm going to leave it like that for now. Okay, so let's find area of the shaded.
Oh, yeah.
Yeah. I know. No. Area of the shaded. Well, that's the area of the circle, right? Which is pi times 4 squared minus what we just found. So that means that 16 pi minus 12 root 3 meters squared.
That's the answer.
Yeah, and if you put it in your calculator, you can get the exact, you can get the approximate answer. Can somebody help me with the approximate answer quickly? Oh, 29.48 it is. Okay, so
29.5 since we're rounding it down.
very good. 29.5. Yeah, 29.5 meters squared. Fabulous. Okay. Whew, let's do the next one then. All right, so now we've got a square outside, a circle inside, a circle inscribed in the square. Okay, so we've got an 8. Okay, so same exact situation, right? This is, so like a square is also a polygon, right? So we can do the same thing. So, no, we're going to find it though. Aha, it's a 45 this time because 360 over 4 is 90. So this is 90. Okay. And when I split this up, this is the apothem. I get a 45-degree angle here. Okay. So now, okay, whenever I have 45-degree angles, I always like to mark the congruent sides. Okay, the congruent legs. All right, now, the 8 is the what of this 45, 90? Hypotenuse. So if that's 8, then each of the legs is 8 divided by root 2, okay? 8 divided by root 2 is how much these days?
4 root 2.
Correct. Okay, so the apothem is 4 root 2, and this is 4 root 2. Well, if that vertical side is 4 root 2, then the entire side of the square is how much? 8 root 2. Whew. Okay. Okay. This A is the apothem of that triangle, but what is it of the circle? The radius. You see how it doubles as both? Oh, yes, yes. Okay. So look, this is the radius of the circle if you ignore everything else. So now I know how to find the radius, the area of the circle, and the area of the polygon. Oh my God, we are good to go. Okay, so the area of the square is 8 root 2 squared. So that's 64 times 2, 128. So the area of the shaded part is 128 minus pi times 4 root 2 squared. Does that make sense? Okay, so this is 128 minus, okay, what's this? 4 squared, 16. Root 2 squared, 2, 16 times 2, 32 pi. Okay, and is it 100.5? No, no.
27.5.
That makes sense. How much?
27.5.
27.5. Okay. Okay, good. Fabulous. All right. Fun, huh? Okay. All right. Yeah. Yeah, they're over there. Okay. So here we need to find the area of the triangle. First, this is 30 degrees. So that means this is 90 degrees. Okay. This is also 90 degrees because it faces a central angle of 180, right? And it's half of it. That lesson we didn't cover, but that's 90 degrees. That was in the circles lesson that we didn't cover. That's why on the quiz too, I gave you guys that information. There was one of those. Okay. Okay, so if this is the short leg, then the long leg is how much? 5 root 3. And this side is 10. So the radius here is 5. Good. Okay. So we know what the area of the circle is, right? Okay, so the area of the shaded part is equal to, okay, the area of the circle, which is pi times 5 squared, 25 pi, minus the area of the triangle. Now look, sometimes we overthink this, but to find the area of this triangle, go back to 6th grade. You've got the base, you've got the height, right? So it's just half times base times height, okay? Once we start doing the fancy stuff, we're all looking at like fancy things, but this is one of those basic cases. So it's 5 times 5 root 3 all over 2. So this is 25 pi minus 25 divided by 2, 12.5 root 3. We'll just leave that like that for now, okay? Oh, it's 56.9. Okay, this one. All right. This is also a good one. Okay, so what shape is that inside? Hexagon. So if I draw those blue sides, how much is each of the blue sides? 10. Okay. And the radius of the circle is also 10, right? Okay, so let's do this. Central angle, 360 over 6, 60. So how much is the top angle?
30.
30. 10 is the what? The hypotenuse. That means the bottom short leg is how much? 5. Good. And this is 5 root 3, the apothem. You see why we needed to do all that other stuff before in chapter, was it 8, 9, 8? Okay. So, one of these sides then is 10. Turns out that's an equilateral triangle over there. Okay? So, all right, so let's find the area of the shaded. Let's see if we can do it in one like one round here. Okay, so it's the area of the outside, pi r squared minus the apothem times, what's the perimeter?
60.
Divided by 2. This is 100 pi minus, okay, this and this gives you 30, 150 root 3. Okay, inches squared. Okay? All right. So area addition postulate, basically, the area of the region is the sum of its parts. You guys know this. Okay, so how do we find the area of the shaded region here? What are we going to do? The total minus the bottom rectangle, right? Okay. All right. So what is the total? How much is this side? Is it 120? So it's
150.
150 because you got to go on both sides. So it's 100 here. 20 is this. And then you've got 25 and 25 on either side, so 150. And then how much is this one?
70.
50.
Yeah.
He was right, 70.
Oh, right, it's 20.
Because 25 plus 25
Mhm.
plus 20.
Right, good, okay. So, the area of the shaded part then is 150 times 70 minus 100 times 20. That's 8,500. Whew. Okay. Okay, to do the other one, let's first figure out what it is that we have. Yeah,
A square, a rectangle,
a rectangle here.
triangle, and then for the circle, you just multiply, divide the, or no, you can just, you don't take the area of the second one, you just take the area of one of the half circles.
Right, so I have two semicircles, which makes one full circle, right? So I have a rectangle, a triangle, and a circle. Okay, so area is, let's start with the rectangle, 32 times 16, plus, how do I find the area of the triangle? Right, 32 times 15 divided by 2, plus pi, what's the radius? 8 squared. So when you can combine two half shapes to make one, you should do that. Okay, good. So all that, I believe, is 953.1. Okay. What do we have here? A triangle and a rectangle. So we're going to do the rectangle minus that little triangle, right? Okay. 10 times 8 for the rectangle. How am I going to find the area of the square? I need a, I'm sorry, the triangle. I need a height here. Huh? So this is 4. This is 4.5. How am I going to find h? Pythagorean theorem works fabulously well. So h squared plus 4 squared is 4.5 squared. Oh. Okay. So someone go ahead and tell me what you get for h. Okay, the area then is the area of the rectangle, minus half times the base, which is 8, times the height, which is 2.06, and I believe that's 71.8 inches squared. Okay? All right, so I don't have factoring for you today, but I have some of this. These are like types of questions that might show up on the PSAT, but in addition to that, it's good review, right, of things we've done in the past. And, you know, apparently there's like a final and stuff coming up at the end of the semester. Did you guys hear about that? I don't know. Okay.
How many questions did you no one told us, so you can't give us one.
It's usually like 50-ish. No. Okay. So the area of triangle ABC is at least 48, but no more than 60. If y is an integer, what is one possible value of x? So first of all, forget about anything that we read here. Okay? If you just happen to be walking around and you saw that on a wall or on a billboard, right? Just that diagram, there should be one thing that pops into your head immediately. It's 2 words actually, right? What do you think, huh? Parallel lines, but I'm thinking of something else, something triangles. Starts with a pro. ends with a portional.
Oh,
Proportional.
Proportional triangles is what should pop into your head, okay? All right, so to do proportional triangles, we always want to compare a smaller triangle with a bigger triangle, right? So we've got the smaller triangle here, sides of 5 and x, and then we've got the larger triangle. This has a side of 12 and a y. So 5 over x is equal to 12 over y. Okay, and what we really need here is the area of triangle ABC. So what's the area of this? It's half times base times height. So 12 times y divided by 2, 6y. Okay? All right. What do we know? We know that the area is at least 48, but no more than 60. Okay, the area is at least 48, but no more than 60. So it's between 48 and 60. So it's 48 less than or equal to 60y less than or equal to 60. Does that make sense? Let's see. 6y is greater than or equal to, so it's at least 48, and it's at most 60. Okay. So what's y? If I'm not, so I don't know if you guys did this in algebra. Did you guys do things like this in algebra? We did it this year, right? So divide everything by 6. We can divide everything by 6 to solve for y. This might be a little bit new to you, okay? Don't worry too much about it. I'm doing it so you guys have exposure, okay? So don't worry too much about it. I just want to like get you guys used to the types of wording of these things. So this is 8, y, 10. Okay, well that's great. We found y, but that's not what we need. What do we need? X. Okay, so what is x? How am I going to find x?
well, 12x equals 5y.
Huh?
12x equals 5y.
Wait, say that again?
12x.
Because it's asking you for one possible value of x, you pick one possible value of y. Pick a possible value of y. 9. So what's x? So, okay, so 5 over x is equal to 12 over 9. 12x is 45. X is 45 over 12. Divide by 3. 15 over 4. Okay? And that's this lesson.